Okay, one more. Find the asymptotes and describe the behavior of the function near those asymptotes by sketching it. So there are two interesting points or interesting x values around this function. There's the place where it equals 0 when the numerator goes to 0, and there's the place where the denominator goes to 0. That one's probably going to produce an asymptote. Let's find out. Here is a number line. We think there might be interesting stuff at -5 and at -4. And we have the x plus 5 factor. We have the x plus 4 factor. And then we have y, which is the first thing over the second thing. Let's see what we get from that. So if x is lower than -5, the x plus 5 comes out negative. If x is exactly -5, we get 0 here. And if x gets any higher than that, then this factor goes positive. With plus 4, we get negative. -5 plus 4 is negative. -4.5 plus 4 is negative. Here we get 0, and then that one goes positive also. So overall, this thing will be negative over negative. 0 over negative, that's fine, that's just 0. Positive over negative. Positive over 0, that's not fine, that's undefined. And positive over positive. Let's see if that's enough for us to get a sketch. Here, the undefined place, this is where we get number divided by 0. That's a vertical asymptote. It's not a point discontinuity. It's not 0 over 0. It's number over 0. So vertical asymptote right there. So, and we know that our function has a x-intercept right at -5. So the point -5, 0 is included, guaranteed. So this function is positive, apparently. Then it crosses through an x-intercept, goes negative, and now it's kind of trapped. It must continue to go negative. It must not hit the asymptotes, so its only option is to curve downward like that. On the other side of the asymptote, this function is positive forever, so it must come down following the asymptote and then curve off like this. But it can never touch the x-axis, because if it did, we would have gotten a 0 or a negative paying off here on our table of our sign table, and that did not happen. We'll see later when we talk about horizontal asymptotes, this thing will have a horizontal asymptote at 1 because the ratio of these two x's is 1 to 1. But for now, suffice to say, this thing will curve outward like that and never reach the x-axis. And that should be all they wanted. So vertical asymptote at -4, and the overall behavior is asymptotic around -4, and there are horizontal asymptotes, which you'll know how to detect shortly.